for photoelectric effect. First is Hertz observation. First is Hertz observation. See what we are going to use. We are going to use this thing. This is a glass tube. This is a glass tube. It will be vacuum created. Okay, it will be vacuum glass tube. You can also name it as evacuated chamber. Evacuated chamber. Evacuated chamber. Okay, then we have two plates. One plate is known as cathode plate. Another plate is known as anode plate. Cathode plate, another one is known as anode plate. This cathode plate is also known as emitter plate. Cathode, and this is anode. Cathode plate is also known as emitter plate, while this anode plate is also known as collector plate. It is then connected to a battery, and then it is connected to a galvanometer. Okay, so what we have a chamber, evacuated chamber. In that evacuated chamber we have two plates. First name is cathode, another one is named as anode. Cathode also known as emitter plate, anode also known as collector plate. This setup will be connected to a battery. Okay, yes. So how it is working, let's see each things one by one. First point, Heinrich Hertz made the discovery of photoelectric emission in 1887 while doing research with electromagnetic waves. Hertz found that when ultraviolet light from arc lamp illuminated the emitter plate, high voltage spark across the detector lobe were amplified. This finding was made during the experimental inquiry into the creation of electromagnetic waves by a spark discharge. It is believed that presence of light on the metal surface allowed free charge particle known as electron to leave more easily. When the light strikes a metal surface, certain electron near the surface absorb enough energy from the incident radiation to cancel out surface positive charge. Okay, so what happened here on cathode plate? See, also remember one more thing, panic. Panic means positive anode, negative is cathode. Anode will be positive and cathode will be negative. Okay, panic, positive anode, negative cathode. Okay, so then what happens? See, we will strike lights, ultraviolet lights on our cathode plate. From cathode plate, electron will jump out after threshold frequency, and that electron is negative charge and this is positive charge. So this electron will go to collector plate, and as the circuit is completed, see here what we have here, from here this charge electron will go and will find the current. Okay, from here electron will go and we will get the current, and that current will be stored here. And how we will know that the current is flowing? This galvanometer will give us a deflection. When suitable lights falls on the cathode plate, there will be emission of electron, and that emission of electron, will get to anode plate, and from that anode plate it will move to galvanometer, and galvanometer will show what? It will show the deflection, and the remaining current will go to battery. Okay, this was the Hertz observation. This was the Hertz observation. Now what? Okay, yes. Now after that, there was two more scientists named as Hallwachs and Lenard. They were performing an experiment. They know what is happening, but they were not able to explain what is happening. So what happened after that? After that, this matter went to Sir Einstein. Okay, what Einstein did, Einstein explained the thing, each and everything. And then this setup today known as Einstein photoelectric effect. Okay, who discovered? Hallwachs and Lenard. Who explained? Einstein. Now this setup is known for what? It is known as Einstein setup. Einstein photoelectric setup. Okay, yes. See, what is there in this topic? We have same evacuated chamber. We have evacuated chamber. Okay, we have evacuated chamber. And I'll make it here somewhere. Yes, what is there? Evacuated chamber. Like this. Okay, this inside this, what you have two plates, anode and cathode. This setup is connected to sorry, the setup is connected to battery and microammeter, and above there will be a voltmeter. Okay, yes, this is how it will look. See, here we have a voltmeter, here we will be having a battery. We'll be having a battery, and here we'll be having a microammeter. Okay, see what is happening here. What we have here, we will be having voltmeter. Here we will be having, yes, here we will be having microammeter, and here we have battery with regulator. Okay, what else we have? We have a glass window somewhere here. Somewhere here we have a glass window. Okay, this is known as, first is cathode. Another one is anode. Cathode will be positive, sorry, anode will be positive, cathode will be negative. We have to remember panic. Okay, we have to remember the panic word, panic. See what is happening here. We are striking a light. We are striking a light on collector plate. Okay, we are striking a light on collector plate. What we will conclude from here, we will conclude that same thing, electron will remove, and that electron will be pulled by anode, and we will feel the presence of electron and current by means of what? By means of microammeter. Okay, by means of microammeter. Now see, what is there here? William Hallwachs and Philip Lenard conducted extensive research on the phenomena of photoelectric emission between 1886 and 1902. Lenard noted that current flow in the circuit when ultraviolet radiation is permitted to fall on emitter plate of evacuated glass tube enclosing two electrodes. The current flow ceased simultaneously with the cessation of ultraviolet light. According to this observation, electron from emitter plate C expelled when UV radiation strike it and drawn by electric field to positive collection plate A. The current flow as electron pass through the glass tube that had been evacuated. Consequently, current flow via external circuit when light strikes the emitter surface. See what was happening here. What they concluded. See what was happening here. I will explain what was happening. Why it was happening, that I will explain in the next topic. Okay, which was explained by Einstein. See what they concluded when the light incident on the cathode plate. Okay, not every time there was an emission of electron. Okay, after increasing the frequency, increasing, there was a certain frequency. After that, electron emission was taking place. This was the first thing. Second thing, they were even observing that if you are increasing the voltage, see there is a battery. If you are increasing the voltage, current will increase, current will increase, and after some time, that current will be flowing constant. Constant means that will be a saturation current. Why it is happening, that we'll see in the next topic, in the next session. Okay, in the next topic, sorry. If we are decreasing like this, what was happening? If we were decreasing this thing, so we would see that the energy will fall. Sorry, not energy, photoelectric current will get down, it will be down, it will get down, it will get down, it will be zero. These things were happening. See what was happening. If you are increasing the frequency, after certain frequency, emission was starting. Okay, that photoelectron emission started, and then after that, photoelectric current was happening. What is photoelectric current? The current which is produced with the help of photons. Then second thing, if we were increasing the frequency, okay, electron emission was increasing. If we were increasing the potential difference, photoelectric current was increasing, again it was increasing, and after it was flowing constant. But if we were decreasing the potential difference, if we were decreasing, our photoelectric current will get decreased, it will get decreased, and after that, it will stops. Why it is happening, that we will study in the Einstein one. Okay, yes, let's see the next one.